Chapter 19, Section 1, Interactive Reader, pages 277 through 284, 19 points. The atmosphere. Characteristics of the atmosphere. Key ideas. As you read this section, keep these questions in mind. What is Earth's atmosphere made of? How do the two types of barometers work? What are the layers of the atmosphere? What are two problems related to air pollution? Page 277. What percentage of dry air is made up of nitrogen gas? N2. What is the atmosphere? Highlight. The atmosphere is the layer of gases that surrounds Earth. The atmosphere is a, highlight, mixture of elements and compounds. We generally call that mixture, highlight, air. The atmosphere protects, highlight, Earth from sun's radiation. It also, highlight, helps keep Earth's temperature stable. The composition of the atmosphere. The atmosphere is made up of three main gases. Highlight, nitrogen, N2, oxygen, O2, and argon, Ar. The atmosphere contains very small amounts of many other gases such as carbon dioxide, water vapor. The graph below shows the composition of Earth's atmosphere. Next to the graph, this graph shows the composition of dry air at sea level. The percentage shown for each gas is the percentage of the volume of the air that is made up of that gas. Highlight, nitrogen, N2, 78%. Oxygen, O2, 21%. Argon, Ar, 0.9%. Other, 0.1%. Nitrogen in the atmosphere. Highlight, bacteria in soil and water called nitrogen-fixing bacteria constantly remove nitrogen from the atmosphere. They change the nitrogen gas into a form plants can use. When animals eat the plants, the nitrogen moves into the animals' bodies. When organisms decay, the nitrogen in their bodies moves back into the atmosphere. Question number 1, what percentage of dry air is made up of nitrogen gas, N2? Answer, 78%. 78%. Page 278. What process adds oxygen to the atmosphere? The amounts of oxygen and nitrogen in the atmosphere are almost constant. What can you infer about the rates of the processes that add nitrogen to the atmosphere and that remove nitrogen from the atmosphere? What can you infer about the rates of the processes that add oxygen to the atmosphere and that remove oxygen from the atmosphere? Explain your answer. Oxygen in the atmosphere. Highlight. For most living things, oxygen is the most important gas in the atmosphere. Continue highlighting. Plants, animals, and other organisms use oxygen to release energy from food. They take oxygen from the air to carry out this process. Highlight. Plants also add oxygen to the atmosphere. Continue highlighting. In the process of photosynthesis, plants use energy from sunlight to make food from carbon dioxide and water. Continue highlighting. One of the products of this process is oxygen gas, which enters the atmosphere. What process, question number 2, adds oxygen to the atmosphere? Answer, photosynthesis. Photosynthesis. Water vapor in the atmosphere. Highlight. When water evaporates, it forms an invisible gas called water vapor. Plants and animals also give off water vapor as part of their life processes. Highlight: water vapor in the atmosphere can condense and turn into liquid water. The liquid water may remain in the atmosphere in, highlight, clouds. It may also fall to the ground as, highlight, precipitation. Highlight: the amount of water vapor in the air changes over time. Continue highlighting. The time of day, season, and location affect the amount of water vapor in the air. Continue highlighting. Air may contain as much as 4% water vapor. Continue highlighting. Air that contains less than 1% water vapor is called dry air. Processes that affect gases in the atmosphere. Gas, nitrogen, N2. How is the gas added to the atmosphere? The decay of dead organisms releases N2. How is gas removed from the atmosphere? Nitrogen-fixing bacteria convert N2 to other forms of nitrogen. Oxygen, O2. Plants and other organisms carry out photosynthesis. Most organisms use oxygen to release energy from food. Water vapor, H2O. Living things release water vapor. Evaporation of surface water also produces water vapor. Condensation converts water vapor to liquid water. Ozone in the atmosphere. Highlight: a small amount of oxygen in the atmosphere is present as ozone, O3. Ozone in the upper atmosphere, highlight, forms the ozone layer. Continue highlighting. The ozone layer protects Earth's surface from harmful radiation. However, certain chemicals can damage the ozone layer. These chemicals include, highlight, chlorofluorocarbons, or CFCs, and nitrogen oxide. Question 3. The amounts of oxygen and nitrogen in the atmosphere are almost constant. What can you infer about the rates of the processes that add nitrogen to the atmosphere and remove nitrogen from the atmosphere? What can you infer about the rates of the processes that add oxygen to the atmosphere and remove oxygen from the atmosphere? Explain your answer. The rates of the processes that add and remove oxygen and nitrogen. The rates of the processes that add and remove oxygen and nitrogen remain the same. You can tell because the rates of the gases in the atmosphere remain constant. You can tell because the rates of the gases in the atmosphere remain constant. Again, the rates of the processes that add and remove oxygen and nitrogen remain the same. You can tell because the amounts of the gases in the atmosphere remain constant. Page 279. Why do you think small particulates can stay in the atmosphere longer than large particulates can? What produces atmospheric pressure? Particulates in the atmosphere. The atmosphere is made up mainly of gases. Highlight, however, it also contains tiny particles of liquids or solids. Continue highlighting. These particles of solids and liquids are called particulates. Large particulates may stay in the atmosphere for only a short time. However, smaller particulates may stay in the atmosphere for years. The table below describes some of the sources of particulates in the atmosphere. Volcanic dust, Tiny particles of rock that are thrown into the atmosphere during volcanic eruptions. Pollen. Particles of pollen that are carried by the wind. Mineral crystals. Tiny crystals of salt and other minerals from the oceans or soil. Ash from fires. Ashes that form when objects burn and that are carried by the wind. Bacteria. Tiny organisms that can be carried by the wind. Question 4. Why do you think small particulates can stay in the atmosphere longer than large particulates can? Answer. Smaller particles weigh less, and the gases of the atmosphere, smaller particles weigh less, and the gases of the atmosphere can hold them longer. Again, smaller particles weigh less, and the gases of the atmosphere can hold them longer. What is atmospheric pressure? The atmosphere is many kilometers thick. Highlight. The weight of the air in the atmosphere presses down on Earth's surface. Continue highlighting. The force of an area of land from all the air above it is called atmospheric pressure. Continue highlighting. Atmospheric pressure acts in all directions, up, down, and sideways. Question 5. What produces atmospheric pressure? The weight of air pressing on Earth's surface. Again, the weight of air pressing on Earth's surface. Earth's gravity keeps 99% of the air in the atmosphere within 32 kilometers of the surface. That's about 19 miles. Highlight. Atmospheric pressure is the highest near Earth's surface. Continue highlighting. As altitude increases, there is less and less air pressing down from above. Continue highlighting. Therefore, atmospheric pressure decreases with altitude. Temperature and water vapor can also affect atmospheric pressure. In general, highlight, as temperature increases, atmospheric pressure decreases. This happens because the highlight particles in a warm gas are farther apart than particles in a cool gas. As particles move farther apart, the pressure on a given amount of area decreases. Highlight, increasing the amount of water vapor in the air can also decrease atmospheric pressure. Continue highlighting. Water molecules weigh less than molecules of nitrogen or oxygen. Continue highlighting. Therefore, air that contains water vapor produces less pressure than dry air does. For example, the pressure in a desert may be higher than the pressure near an ocean at the same temperature. Page 280. What are 3 units used to describe atmospheric pressure? What happens to the level of mercury in the tube when atmospheric pressure increases? Do the sides of the container in an aneroid barometer probably bend inward or outward when air pressure outside the barometer increases? Explain your answer. Measuring atmospheric pressure. 3 common units used to describe atmospheric pressure are atmospheres, ATM, millimeters of mercury, mmHg, and millibars, MB. Continue highlighting. Standard atmospheric pressure of dry air at sea level Continue highlighting. It is equal to 1 atmosphere, 760 millimeters of mercury, or about 1,000 millibars. Continue highlighting. Scientists use a tool called a barometer to measure atmospheric pressure. There are two main types of barometers. Highlight: mercurial barometers and aneroid barometers. The diagram below shows how a mercurial barometer works. Question 6. What are 3 units used to describe atmospheric pressure? Atmospheres, ATM. Millimeters of mercury, mmHg. Millibars, MB. Again, that's atmospheres, ATM. Millimeters of mercury, mmHg. Millibars, MB. Left-hand side of the diagram. This scale shows how high the mercury has risen in the tube. Bottom left, when atmospheric pressure increases, more mercury is pushed up into the tube. Right side, in a mercurial barometer, the height of mercury in a tube indicates atmospheric pressure. Question 7. What happens to the level of mercury in the tube when atmospheric pressure decreases? It lowers. It lowers. Mercurial barometers were common in the past. However, because mercury is harmful, most scientists no longer use them. Instead, they use aneroid barometers. Highlight: an aneroid barometer contains a sealed metal container. Continue highlighting. Most of the air inside the container is sucked out before the container is sealed. Continue highlighting. When the atmospheric pressure changes, the sides of the container bulge inward or bulge outward. Continue highlighting. The movements of the container sides move a pointer which indicates the atmospheric pressure on a scale. Barometers can also act as altimeters. Highlight: an altimeter is a tool that measures altitude or height above sea level. Remember, the atmospheric pressure decreases as altitude increases. Therefore, as a barometer is carried to highlight higher altitudes, the highlight pressure reading it shows will decrease. Question number 8. Do the sides of the container in an aneroid barometer probably bend inward or outward when air pressure outside the barometer increases? Explain your answer. Inward, because the air will press on it more. Inward, because the air will press on it more. Page 281. What do scientists base the division of the atmosphere on? At what altitude does the minimum atmospheric temperature occur? Which layer of the atmosphere is the thickest? What are the layers of the atmosphere? Remember that atmospheric pressure decreases as altitude increases. Highlight: the temperature of the atmosphere also changes with altitude. Continue highlighting. However, it does not constantly decrease with altitude like pressure does. Continue highlighting. There are 3 altitudes at which temperature changes suddenly. Continue highlighting. Scientists divide the atmosphere into 4 layers based on these changes. The diagram below shows the temperature and pressure in each layer of the atmosphere. Question 9, what do scientists base the division of the atmosphere on? Answer, temperature changes. Temperature changes. Under the diagram, unlike pressure, temperature does not decrease constantly as altitude increases. The bottom axis is temperature in degrees Celsius. The vertical axis, the left-hand side, is altitude in kilometers. Altitude in kilometers. Question 10. At what altitude does the minimum atmospheric temperature occur? Highlight on the left-hand side at 80 degrees the curve of the line between thermosphere and mesosphere. Again, highlight on the left-hand side of the curve at 80 kilometers between thermosphere and mesosphere. Your answer is 80 kilometers. 80 kilometers for question 10. Question 11, which layer of the atmosphere is the thickest? Highlight a line all the way across the 10-kilometer mark. So where you find the 10 on the left-hand side, run a line all the way across the diagram. Go up to 42, just above the top of the stratosphere, ozone layer, and run another line all the way across. That layer, which is the thickest, is the stratosphere. So your answer for question number 11 is stratosphere. The troposphere. Highlight. The troposphere is the layer of the atmosphere that is closest to Earth's surface. Continue highlighting. All of the weather on Earth happens within the troposphere. Continue highlighting. Almost all of the water vapor and carbon dioxide in the atmosphere are in this layer. Within the troposphere, highlight, temperature decreases steadily as altitude increases. The troposphere reaches to about 12 kilometers above Earth's surface. Page 282. How does temperature change with altitude in the stratosphere? Why does temperature increase as altitude increases in the thermosphere? The stratosphere. At about 12 kilometers above Earth's surface, the temperature suddenly stops decreasing as altitude increases. Highlight, the area in which this sudden change happens is called the tropopause. Continue highlighting. The tropopause separates the troposphere from the stratosphere. Continue highlighting. The stratosphere reaches from above 12 kilometers above Earth's surface to about 50 kilometers above Earth's surface. Continue highlighting. Most of the ozone in Earth's atmosphere is in the stratosphere. Continue highlighting. Ozone in the stratosphere absorbs solar radiation and becomes warmer. Continue highlighting. Thus, the temperature in the stratosphere increases as altitude increases. In the lower stratosphere, the temperature is about negative 60 degrees Celsius. In the upper stratosphere, the temperature is about 0 degrees Celsius. Question 12. How does temperature change with altitude in the stratosphere? Answer, it increases. It increases. The mesosphere. At about 50 kilometers above Earth's surface, temperature suddenly stops increasing with altitude. The area in which this change happens is called the stratopause. The stratopause separates the stratosphere from the mesosphere. Continue highlight. The mesosphere reaches from about 50 kilometers above Earth's surface to about 80 kilometers above Earth's surface. Continue highlighting. Within the mesosphere, temperature again decreases as altitude increases. The upper mesosphere has a temperature of about negative 90 degrees Celsius. The thermosphere. Highlight. The layer of the atmosphere above the mesosphere is called the thermosphere. Continue highlight. In the thermosphere, temperature increases as altitude increases. Continue highlighting. This increase happens because the nitrogen and oxygen atoms in the thermosphere absorb solar radiation. The temperature in the thermosphere may be as high as 1,000 degrees Celsius. However, because there are so few atoms in the atmosphere or in the thermosphere, temperature is very difficult to measure. Layers of the atmosphere. Troposphere. As altitude increases, pressure decreases. As altitude increases, temperature decreases. Stratosphere. As altitude increases, pressure decreases. As altitude increases, temperature increases. Mesosphere. As altitude increases, pressure decreases. As altitude increases, temperature decreases. The thermosphere. As altitude increases, pressure decreases. As altitude increases, temperature increases. Why does temperature increase as altitude increases in the thermosphere? Answer: nitrogen and oxygen atoms absorb solar radiation. Nitrogen and oxygen atoms absorb solar radiation. Page 283. What causes auroras to form? Why can't the air in a temperature inversion move away? The ionosphere and the exosphere. Highlight. The thermosphere is the uppermost layer of the atmosphere. Continue highlighting. Scientists often divide the thermosphere into two layers, the ionosphere and the exosphere. Continue highlighting. The ionosphere is the lower part of the thermosphere. It reaches from about 80 kilometers to about 400 kilometers above Earth's surface. Highlight. Within the ionosphere, solar radiation can break apart atoms or molecules to form ions. Continue highlighting. The ions can interact with the solar radiation to form auroras. Continue highlighting. Auroras are bright lights that seem to flow through the sky. Continue highlighting. The exosphere is the layer of the thermosphere that reaches from above the ionosphere into outer space. Scientists are not sure where the upper boundary of the thermosphere is. Therefore, they have different definitions for where the edge of the exosphere lies. What causes auroras to form? Question 14. Ions in the ionosphere interact with solar radiation. Interact with solar radiation. What is air pollution? Highlight. An air pollutant is any substance in the air that is harmful to living things. Continue highlighting. Air pollution is a general term for all air pollutants. Continue highlighting. Natural processes such as volcanic eruptions can cause air pollution. However, today, most of the air pollution in the atmosphere comes from human actions. For example, highlight, burning fossil fuels produces a great deal of air pollution. Air pollution can cause many problems. One common problem caused by air pollution is smog. Highlight, smog is an air pollutant that forms when exhaust from vehicles reacts with sunlight. Sometimes weather can make air pollutants more harmful. One example of this process is a temperature inversion. The flowchart below describes how a temperature inversion forms. Highlight, a layer of warm air forms above a layer of cool, polluted air. The warm air is less dense than the cool air. Highlight, the warm air stops the cool air from rising and leaving the area. Highlight, the cool, polluted air is trapped close to the ground. Question 15. Why can't the cool air in a temperature inversion move away? Answer, the warm air over it is less dense. The warm air over it is less dense and holds it down. And holds it down. Again, the warm air over it is less dense and holds it down. Page 284. Complete the Venn diagram below to compare the stratosphere and the troposphere. How does an aneroid barometer measure atmospheric pressure? Name the three most abundant gases in the atmosphere and identify the percentage of the atmosphere that each makes up. Why is air pollution often worse in cities than in rural areas? Question number 1, answer can be found on pages 281 and 282. Under troposphere on the left-hand side, temperature decreases with altitude. Temperature decreases with altitude. Closest to Earth, air pressure highest. Air pressure highest. In the center, layers of the atmosphere. Pressure decreases with altitude. Pressure decreases with altitude. On the right-hand side, stratosphere. Temperature increases with altitude. Temperature increases with altitude. Has the ozone layer. Air pressure lower. Air pressure lower. Question number 2. Answer can be found on page 280. The sides of a sealed metal container are sucked in. The sides of a sealed metal container are sucked in and out as pressure changes. As pressure changes. Again, the sides of a sealed metal container are sucked in and out as pressure changes. Question number 3. Answer can be found on page 277. Nitrogen, 78%. Oxygen, 21%. Argon, 0.9%. Again, nitrogen, 78%. Oxygen, 21%. Argon, 0.9%. Question number 4. Answer can be found on page 283. There are more things to burn fossil fuels. There are more things to burn fossil fuels.